So, how does this work? Just press the button here. This is quite a different type of talk. I'm going to talk about transformations in food systems. Top button, okay. There we go. This is a photo taken actually from my back garden, and even I'll grudgingly admit this was quite beautiful. I'm generally not a fan of intensive food production systems. As an ecologist, I'm very aware that they are very damaging for wildlife. England, as an example, has 70% of arable, often intensive or improved grassland, and just 1% of semi-natural grassland cover left. And we can do studies, for example, looking at long-term monitoring data sets. This is satellite data, looking at the amount of natural habitat versus farmland. And we can look at sort of counts of some populations. This is a butterfly population at one site increasing over time. And we have this type of data for birds and butterflies, a few groups. And this population crashed suddenly. There was a drought in 1995, and then there was some recovery. Now, actually, when you analyze these data, you can quantify this extent of this crash, and those crashes are much more severe in landscapes where there's more intensive land cover. Just to give you one summary, we looked forward, combining this with IPCC scenarios for obviously increasing droughts. And the sort of headline result, a headline result, I guess, is that the probability of persistence for drought-sensitive species, so this is about 10% of our butterfly fauna. And if this is true for all groups, that's quite a substantial part of our, England's wildlife, is that the probability of persistence drops from 50% to 10% when you have less habitat and it's more fragmented. These two scenarios are not very extreme. They're actually just one standard deviation around the mean of the types of landscapes that we have in England around our monitoring sites, which are fairly representative of the country. So, and this is under quite a benign climate change scenario. So quite worrying results. Beyond wildlife, we can look at pollinators. That was statistical modeling. This is process modeling, a validated process model to produce this map of pollinator natural capital. And you can zoom in and look at pollination. This is solitary bees, important for apple crops. And you can, for example, you can look and play forward these types of models under intensive land use and see how pollinators will suffer under landscape intensification. So, as I said, I would look at this kind of scene and be a bit depressed, but I'm quite aware that others have different value sets and would look at this and say, it might make them feel of security and self-sufficiency. And we need a food system which caters, delivers a range of benefits and addresses multiple value sets as much as possible. Now, there are a number of frameworks, of course, for thinking about multiple objectives, not least the Sustainable Development Goals. In the UK, there's a new policy initiative called the National Food Strategy, trying to think about multiple objectives from the food system: healthy, safe, affordable food, humane agriculture, well-paid jobs. And you could use the terminology here, systemic efficiency, which is Tim Benton's paper describes this. And the idea is, rather than having efficiency in a very narrow sense, just increasing yield, you're thinking, potentially improving nutrition, but even, improving environmental outcomes as well, and a whole range of objectives. So you want to increase the systemic efficiency of the system. Now, our current global food system obviously doesn't do that. These are some statistics. I won't go through them. My highly scientific emoticon indicator here will show you that it's not looking good. The food system does provide calories. They're not very well distributed amongst the global population, and some jobs. But obviously in 2050, even those aspects under climate change and automation are in question. So it's not addressing multiple objectives as we'd like it to. So of course we need the food system to transform in some way. Everyone's saying it, transform the food system, but how do we do that? Well, it's complex, of course, the food system. We're not just talking about production here. We're talking about the whole value chain from farm to fork, or from fin to fork, if you will. Thinking about manufacturing, transport, finance, agribusinesses, and the governance of all these systems. And it's the links, it's the relationships between all these people in terms of economic relationships, but even social relationships. This is millions of people, if not billions. The food system touches all of us. And how do we transfer and transform this huge system? But of course we have to. The food system is nested within an environmental system, which obviously, as I've mentioned, is is degrading this environmental system, and it's threatening its ability to persist into the future. Sometimes these kind of conceptual model used in resilience studies might be useful. This ball and cup diagram shows the system as some kind of ball. Often they're used when you want to maintain the resilience of a system. You want to maintain a resilient ecosystem, and we don't want it to tip into an undesirable state where we might lose ecosystem services. But you can turn that around and say, well, actually, the system might be in an undesirable state, and we want it to transform, but there's some kind of resistance here that we need to overcome. Now, whether you regard the food system in an undesirable state or it's obviously in some kind of trajectory, perhaps. I have a PhD student working on this, actually, trying to look at whether 200 countries, whether there are 200 different ways that food systems are transforming, or whether there are just a number of archetypes of food system transformation. And what are the outcomes of those archetypes in terms of environmental, social outcomes? And maybe can we tailor solutions that are more bespoke to the type of archetype? So I'm not going to present that today, but I have some results, and it'd be good to get feedback if people are interested. So let's say you regard this as a dynamic system, then maybe this framing, this concept, similar kind of diagram is good from Shipansky. And you can imagine this diagram was coming out of the page, and this system here can transition into a better state, but equally it could get even worse. And the question is, how do we steer and navigate the system? You can see here they've listed some points here, which some of these are outcomes, increased equity and justice. This is what we want from the transformed food system, but others are kind of ways of getting there. So agro-ecological management, diversity of distribution networks. So we're starting to get to the kind of innovations that we want to improve that food system. Now, there's obviously lots of types of work on this. This is some from the European Environment Agency, thinking about how types of innovations for transforming the mobility, food, or energy sectors. Obviously, let's just focus on the food for now. There's some about technical innovations, precision farming, valuing food waste, radical innovations, they call them, no-till farming, for example. Also social and behavioral innovations, business model innovations, infrastructure innovations. Now, obviously, there's lots of different ideas here. One of the questions is how we go from these small niches and upscale them to make them more mainstream. And there we need to think about the lock-in mechanisms that are constraining those transformations. This is from IPES Food, and the IPES Food have done quite a lot of thinking about lock-in mechanisms. This is the EU food system, this little boat. It wants to get here to this multi-objective, more systemic efficiency. In this case, they're given an example of a vicious cycle where techno-fixes might sideline real solutions. So we might get locked into focusing on precision agriculture for large-scale monocultures, and they would argue that this is only one part of the solution, and this might kind of lead us to get stuck in some space which doesn't allow us to deliver the full transformation that we want. So the types of work that has looked into these lock-in mechanisms tend to have just looked at 5 or 6 at a time. I was fortunate enough to be involved in this workshop where we looked at a whole range of different mechanisms. We had people from business studies, development studies, political economy, agriculture, ecology. Tim Benton was involved as well. And we were trying to identify different types of mechanisms. So, for example, on the left column, knowledge constraints. I'll just give you some examples. A retailer might want to, sell more sustainable products, but it's very difficult to know what is a sustainable product because of the lack of information. Economic and regulatory constraints. This is something that, for example, I'm seconded with DEFRA at the moment under a program that Ian Boyd set up, Systems Research Program. And DEFRA are very good at economic and regulatory issues and knowledge constraints. One example, if I just go back, is risks to first movers. So there are obviously economic risks to first movers. Let's look at number 10, capital investments. You may have sunken a lot of capital into investments, so it's very hard to change the way you do things. A big one, though, is perverse subsidies. We pay farmers to often farm in a way which is damaging to the environment. If we jump across now to biophysical constraints, this is where, as an ecologist, I'm perhaps more comfortable. Insufficient pollinators and natural enemies. If we've destroyed those spiders and ground beetles and ladybirds, it's very difficult to farm in a way which is free of pesticides. There's a pesticide lock-in. And until we restore those natural habitats and bring back the natural enemies, we're kind of locked into that intensive system. Soil health is another one. If we've degraded the soil quality or compacted the soil, we might be locked into using heavy chemical inputs. But I want to come back to this category that I missed now, which is socio-cultural constraints. And I think these are really important, but are often neglected under a lot of policy analyses. And these relate more to sort of psychology or behavioral economics or even philosophy and ethics. There's risk to first movers here. I'm not very good at this device. Risk to first movers here as well, not just in economic sense, but when you do something differently, you break away from the pack, from the crowd. There's a kind of social risk involved in that. Belief in technofixes, number 17. People think we don't need to solve the pollination crisis. We can just invent robotic pollinators, or we can put mirrors up in space to solve climate heating. Now, there's a role, of course, for technofixes, but often these technical fixes they improve things in a very narrow efficiency. So putting mirrors in space might reduce the heating of the Earth's surface, but it's not going to improve ocean acidification. And it's probably going to have a lot of other side effects as well. So when we want this more sort of holistic, systemic efficiency, this kind of magical thinking of technofixes has quite a limited role. What I want to focus on is limited collective identity. You can maybe explain to people that the environment is declining, but they might say, I don't really care, I just care about my family, and I don't really care about the environment on the other side of the world, or other people on the other side of the world, or people in 2050. And it's very difficult to make a rational argument here. This is about values. I've written a book about this, and it's about thinking about how these big global problems of global food systems, actually some of the solutions lie in our individual mindsets. When people feel more connected to nature and other people, they tend to have more pro-environmental behaviours. So they buy sustainable food products, they reduce their food waste, they buy fair trade products. Now, this is not all to say that all the solutions lie in kind of this environmental psychology type research that I review here. But equally, the solutions don't lie just in addressing perverse subsidies, and they don't just lie in improving soil health. We need to work on all these mechanisms rather than just picking a few piecemeal. Otherwise, we'll never transform and get enough activation energy to kind of tip that system. And very quickly, just to end, and I'm not going to go into details here, but each of those lock-in mechanisms, you can target interventions. And really, just to highlight that this is saying that those interventions the lock-in mechanisms occur at levels of individuals, businesses, or government. But equally, the interventions can be instigated by individuals, businesses, and governments. And I give examples here we give examples in the paper. But it's really to highlight that it's cross-scale and cross-sectoral, and it's not all top-down governance. But of course, government can facilitate these different actors to take those interventions. And we need a much more coordinated approach to addressing all the mechanisms that lock in these systems. Otherwise, we won't effectively transform those systems. And although then we'll have a kind of food system which looks beautiful, not just in sunset, but also delivers a whole range of multiple benefits that we really want these systems to deliver. Thank you.
Is there a clarifying question? Yep.
I'm concerned that you talk about individuals rather than groups. And one of the ways we know things, each clump can be organized and be a group. Individuals can't do much by themselves, but you might want to rethink individuals rather than what we sociologists would call civil society, which means people acting together.
No, that's an absolutely fair point. I think in the paper we refer to those individual level. In the book I mentioned, it's all about actually this idea that we're not individuals, and when people feel more of a group and they have a more collective sense of identity, that's when you get those pro-environmental behaviours. So, I absolutely agree.